Okay, today we're going to talk about area of similar figures. We've already talked about perimeter and area of a bunch of different shapes. And now I'm going to ask you a question. What is length? What is it to these figures? And you might think, well, duh, but no, I actually literally want to talk about the difference between length and area. When I say what's the perimeter? Because I'm going to find the perimeter of the first figure and I'm going to find the perimeter of the second figure. What are we doing? We're going to add up what? All the sides. What does that mean? It's the length of a side. It's in linear measurement. It's like a line plus a line segment plus a line segment. Okay, so the perimeter of this figure would be 12. Okay, and the figure of the bigger one would be 10, 18 plus 4, 24. Okay, now, the ratio of the sides of these figures, look at them all. Ratio of the sides. If I compare 4 to 8, and 5 to 10, and 3 to 6, what do you get from all of those? Okay, so if you pick pair, 4 to 8, say, and you reduce it, what do you get? 1, 2, 2. I heard several of you saying, all right, 1 to 2. Now, let's go over to the perimeters. We got 12 to 24. But how do those numbers compare? What ratio are they actually in if you reduce? 12 divided by 12, 1. 24 divided by 12, 2. 1, 2, 2. Okay, next I want to talk about the ratio of the areas. So I'm going to find the area of the first one. And I'm going to find the area of the second one. Now, I'm going to remind you that area of a triangle is base times height divided by 2. So, the base is 3, the height is 4, so the area of this triangle is 3 times 4 divided by 2, and that's 12 divided by 2, which is 6 square units. Now, the previous questions when we did perimeter were not in square units, they were simply in units. These are very different types of things. When we're doing the area, we're finding out how much space that figure takes up on a surface. Okay? Very different than lines added up. So the area of the second figure, base times height divided by 2, would be 6 times 8 divided by 2, and that would be 48 divided by 2, which is 24 square units. Okay, let's compare 6 to 24. Well, wait a minute, that's not 1 to 2, is it? 6 goes into 6 once. 24 divided by 6 is 4. Okay, I'm looking for you to figure something out here in a little bit. So we're going to look at the next picture. These are not looking like squares to me. Excuse me, and my apologies. The ratio of the sides, though, would be 2 to 9. What's the perimeter of a square with one side that's 2? The perimeter of the first one would be 4 units. The perimeter of the second one would be, you don't really need to add up all those 9s. You could multiply by 4 because there's 4 congruent sides on a square. 4 times 9 is 36 units. Okay, so the ratio of the perimeters is 4 to 36. But what is that reduced? 4 goes into 4. Wait, I can't divide that, but 4 goes into... The ratio of the sides was 2 to 9. Did I add that up right? I just did perimeters and I put it... What did I do? Oh, this should be 8. That's no wonder there's something wrong there. Oh my goodness, thank you so much. I just didn't even do... I said this twice already today. I certainly didn't do that then, and I'm like, wait, this is all screwed up. What did I do wrong? I can't add, apparently. Otherwise, I was thinking of forward to area. My bad. So 8 units for the perimeter of the first one. 36 is the correct. Now, this does not reduce, this reduces, but what do we divide both of those by? The common factor would be 4. 8 divided by 4 is 2. 36 divided by 4 is 9. The ratio of the perimeters is supposed to come out to be the same as the ratio of the sides. All right, now let's look at area. Glad somebody spotted that. I just wouldn't even be able to think. I was on the spot. All right. Area of the first figure. Now I'm going to get that part right. Area of this thing will be 2 times 2, which is 4 square units. Area of the second one will be 81. You multiply 9 times 9. And 4 to 81 doesn't reduce. So it's just 4 to 81 for the ratio of the areas. Notice anything about the numbers yet? Those are square units. See if we'll get that after the next one. We didn't answer that question yet. Ratio of the sides, which in this case is going to be, we're going to compare the radii, 3 to 7. What is the perimeter of a circle called? The circumference. Okay, circumference is the perimeter of a circle. Circumference is pi times the diameter. So the circumference of the first figure would be pi times what? Yeah, 6. The diameter would be 6. The circumference of the second figure would be pi times 14. All right, now ratio of the perimeters, which is the circumference for a circle, is 6 pi to 14 pi. Now I want you to look at what I wrote there. You're not going to have to keep on doing all these perimeters, by the way, in all these areas. I'll show you why in a minute. But 6 pi to 14 pi, what could you cancel out if you wrote that fraction? Pi's and divide by 2, reduce it. That'd be 3 to 7. All right, now area. Area of the first figure. Remember, area is pi r squared. So the area of the first one is pi times 3 squared, which is 9 pi. The area of the second one, pi times 7 squared. So that would be 49 pi. If you compared 9 pi to 49 pi, you would cancel out the pi's to reduce it. And that would give you 9 to 49. What? Here? I'm looking for what you can do to get this filled out without doing all this work. Here's the generality. If the ratio of the sides is A to B, what's the ratio of the perimeters? A to B. What would be the ratio of the areas? A squared to B squared. That's what we were looking for. We were trying to notice that when we actually physically did it, we found out there's an actual pattern. Ratio of, why are perimeters and sides the same? What type of units are they? They're linear units. They're just length. Length and length, same ratio. Okay? Area, another story. That's different. You have to square these to get that. So, ratio of the sides, if it's A to B. And then the ratio of the sides squared is A squared to B squared. If you want to go in the opposite direction, well, we'll talk about that in a minute. So we're going to look at some problems. From each pair of similar figures, find the area of the shaded figure. All right, I want to know the area of this big guy. Okay? I don't know how to set up that proportion until I find out the ratio of the areas. So you can tell me what the ratio of the sides are. All right, the similarity ratio is the same as the side ratio. So the similarity ratio or ratio of sides, those are one and the same, would be 2, 2, 6. We're going to reduce that. What would that be reduced? 1, 2, 3. Okay, now area ratio. What would it be? Well, you take those and you square them. It'd be 1 squared to 3 squared. You can actually write your proportion without even acknowledging what these values are, but it would be 1 to 9. All right, so we're going to write our proportion. 1 is to 9 as, now I want to find the area of which figure, and it's the shaded one. So I have the area given to me of the smaller one. Where would the 20 go in my proportion? Got to put these in the right place. I need to use 20, and I'm going to use an A. Is it 20 over A or A over 20? One is a lot smaller than 9. I heard some wrong answers. That's why I'm concerned. Small to large, small to large. It has to be 20 over A. I heard some people say A over 20. You guys got it? All right. We got to be in the right position. 1A, not some of you said it correctly, but some people were not thinking it wrong, so I want to make sure we clarified. All right. So now, how many of you do this when you did a proportion before? Cross, multiply, and divide. Like this. Yes? Some of you got used to just doing 1A equals 9 times 20 and then dividing. But you can do multiply, cross, and divide by the other one. Cross, multiply, and divide. Boom. So the area for this, 9 times 20 divided by 1. I'm going to want you to do that on some of the problems. That's why I'm bringing it up. So the area for this one would be just 9 times 20 divided by 1, which is 180 square inches. Cross, multiply, and divide. Number 2. Same idea here, except I got some ugly numbers, and that's why I'm telling you I don't really want to, I can get these squared and everything else, but I'm just going to write it out. I'm going to say this side compares to this side. So the sides ratio, we're just going to say 10.5 to 15.5. Now there's a way for your calculator to turn this into fractions, but this doesn't look very nice when you do that. It's still gross numbers. All right, but if it asks you for the scale factor, then you would want to do it. Since it's not asking us for the scale factor, I'm just going to go for it. The ratio of the sides would be that, so the areas would be 10.5 squared to 15.5 squared. We can type that on our calculator just like that. Now, where do I put 200? Where'd the 10.5 come from? The first figure. The area of the first figure is 200. It has to go on the top. Area of the second figure would be on the bottom. Is there any confusion as to why it has to be 200 over A? I mean, we did a lot of similarity problems before. Dang, 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 dang. All right. Now, I'm going to type it just like this. I'm going to go 15.5 squared times 200 divided by 10.5 squared. So I'm going to clear this out so you can see. 15.5 squared. Was that my first one, right? And I have to multiply that times 200. And then I have to divide by 10.5 squared. All right, so the area of the bigger figure, bang, it's 435.8. Square centimeters. Any questions about that? Does anybody have a problem with how I calculated that? You multiply, cross, and divide. All right, scale factors and missing measurements of similar figures. You can also use the areas of similar figures to find the scale factor. So if your areas are squared and your scale factors are not, how are you going to go from area back to scale factor? Talk about that right now. All right, we already talked about if the ratio of the sides is A to B. Then the ratio of the areas would be ratio of the sides squared, A squared to B squared. Now, if you were given A squared to B squared, how could you go back to there? Unsquare them, which is square root. Square root of A squared to the square root of B squared. So you would, if you want to go from here back to here, you take the square root. Good? All right. For each pair of similar figures, use the given measure areas to find the scale factor from the unshaded to the shaded figure, then find x. All right. So I got a ratio of the areas. Our ratio of 54 to 216. Well, you could have your calculator reduce this for us, and that would give you the scale factor. Let's see what it is. Scale factor would be 54 divided by 216. You can hit math enter. And you get a reduced fraction of 1/4. Okay. I got the scale factor of 1. Oh, excuse me. It's not 1 to 4 yet. This, I just wrote that in the wrong place. My bad. I need to write this equals 1 to 4. The area ratio of the areas is 1 to 4. Now, scale factor, you'd have to unsquare those. So it's going to be the square root of 1 to the square root of 4. And that's going to be 1 to 2. Right? Now that I have the scale factor, I can find x. 1 is to 2 as 8 is to x. Okay, so once I find the scale factor, I can find a missing side. 1 is to 2 as 8 is to x would give me 1x equals 16, or 2 times 8 divided by 1, we get x is 16 inches. Okay? 4. Not all the problems have beautiful answers. I'm going to check out how 296 compares to 169, and then I'll probably show you something else. If I type in 296 divided by 169, excuse me, and I hit math, enter, it didn't reduce. Okay, so I'm going to tell you right now, this isn't going to be as pretty as the last problem. What do I have to do to go backwards, though, from area ratio? I need to take the square root of them to get the sides ratio. All right, the sides would be in a ratio of the square root of 296 over the square root of 169. So I just had to unsquare it. Now, if I want to find a missing side, then I can set it up. Since I started with this first figure, I'll start with it again. 28 would go on top, x on the bottom. I'm going to go ahead and type this whole mess to find x. The scale factor is not a pretty scale factor for this problem. Okay, it doesn't. 296 and 169. If you take the square root of those, etc., it's not going to be pretty. But let's find the side. Let's type in square root of 169 times 28. Now, careful when you do this. Square root of 169. When you get, I think almost all the calculators, right? Don't you guys have to push the arrow button to get out of there? All right, what were we multiplying that by? Times 28. Okay. All right, now we want to divide that by the square root of 296. So you can just type this all in at once, and we're going to get a decimal that's not all that nice. 21.2 is the answer to the missing side, and it is in feet. All right, so I set up a proportion. If you want to do side lengths, you have to unsquare the areas. So that's why we took the square root. Science project. Matt has 2 posters for his science project. Each poster is a rectangle. The length of the larger poster is 11 inches. The length of the smaller poster is 6 inches. What's the area of the smaller poster if there's a larger poster is 93.5? Well, it's telling us we have a length and a length. So we can say the sides are in a ratio of 11 to 6. Okay, if the sides are in a ratio of 11 to 6, then the areas are in a ratio of 11 squared to 6 squared. We're trying to find the area, and I want to find the area of the smaller poster. So I'm going to say 11 squared to 6 squared equals, that's the area of the smaller poster, if the larger poster is 93.5. So where's the 93.5 go? Which is larger, 11 squared or 6 squared? 11 squared. It says the area of the larger poster is 93.5. That has to go on top, yes. We want to find the area of the smaller poster, so it'd go on the bottom. I have the bigger number on top. Now, you could have evaluated the 11 squared, which is 121, and 6 squared, but you don't have to. We could just type it like this. So we're going to multiply across and divide. So we're going to go 6 squared times 93.5, or you can do 36. And then divide by 11 squared. Okay, we're expecting a number smaller, and so there it is. It should have been smaller. Typed it in right, 27.8. And that'll be in square inches. Now, basically this last part, did I go too fast? Right. The ratio of two sides, the sides of two similar figures is 5 to 7, or 5 over 7 as a fraction or as a colon. The perimeters then would also be 5 to 7, and the areas would be 5 squared to 7 squared, but that we could say is 25 to 49. All right, let's go to the ISN now, please, and then we'll come back to the homework. All right, after all that, I'm hoping we can fill this one in kind of quickly. My apologies in that these don't look like squares at all, do they? What do they look like? Rectangles. Yeah, those are terrible squares. They're not square. They're not drawn right. Not to confuse you, but I don't know what happened. It got stretched or something. But anyway, the sides are in a ratio of 3 to 10. So what's the ratio of the perimeters? 3 to 10. Length, length. Okay, this is a length. This is a length. The ratios are the same. This is not length. This is square units. Okay, so we square these. 3 squared to 10 squared, and we can write 9 to 100. Okay, area is not the same as length. Similar rectangles, here it is generalized. If you have A to 2A, the ratio of the sides would be, what happens with the A's? Yeah, they would cancel out, giving you 1 to 2. Okay, then the perimeters would be also 1 to 2. And areas, 1 squared to 2 squared, which we would write 1 to 4. Okay, we've got some, this is just another, what we had on our paper. We had A to B, and that's sort of like what I labeled. I think you're missing this, aren't you? In the ISN? Something got screwed up when it got printed. Yeah, it doesn't say ratio of sides, ratio of similarity, scale factor. These all mean the same thing. You may want to add this, please. Ratio of the sides equals the ratio of similarity, which equals the scale factor. These are all the same. Okay? So if the ratio of the sides, which is also the ratio of similarity, which is also the scale factor, if this ratio of the sides is A to B, then the ratio of the sides squared, or the areas, are A squared to B squared. All right, if you wanted to go backwards, we decided that you would need to take the square root of A squared, square root of B squared, and that would put you back to A to B. I hope that makes some sense, and you can know that if you want to do back to the ratio of the sides and you were given areas, you have to take the square root. All right, let's do some examples. We've got find the scale factor, which is the ratio of the sides. It tells you that JKL, triangle JKL and triangle PQR are similar. The area of triangle JKL is 40. I'm going to jot that down right here. Square inches. And we're going to be finding the area of PQR. Okay, the ratio of their or scale factor is 10 to 12, which reduces to 5 to 6. The ratio of their areas then would be 5 squared to 6 squared. You can leave it like that, or you could simplify it to 25 to 36. We're going to find the area by writing a proportion. So we're going to say 25 over 36 equals, which one goes on top? A or 40? Okay, we want to find the area of PQR. So the A is on the bottom because we started off 10 to 12. We keep going with first to second. So 40 on top, A on the bottom. So we now cross multiply and divide, which if you want to write down what you're calculating, it would be 36 times 40 divided by 25. Cross multiply and divide. Okay, and you probably got 50, well, you should have gotten 57.6 square inches. I think you have some reason the title of this page is actually at the bottom of the first page, so it's scrambled somehow. I need to fix that for next time, next year. Ratio of areas continued says scale factors and missing measures and similar figures can be found. You can use the areas of similar figures to find the scale factor between them or missing measure. You got parallelogram ABCD is similar to parallelogram FGJH. Find the value of x. If I want to know the length of a side, I need to know the ratio of the sides. I don't have that, but I can figure it out by using the ratio of the areas. So the ratio of the areas is 64 to 49. If you want to know the scale factor or ratio of the sides, you would have to go backwards. So we have to unsquare, which is taking the square root. And that would be 8 to 7. All right? Use this scale factor to find the value of x. So you set up a proportion. You take 8 over 7 equals x over 10 or 10 over x. I started off doing 64 to 49. I got 8 to 7, so it's the bigger one, 10 to x. Cross multiply and divide, you're going to get a weird decimal. So we got to type 7 times 10 divided by 80. 70 divided, not by 80, by 8. 70 divided by 8. Are we getting 8.75? That's not a weird decimal. 8.75 meters. And I did not round because its decimal stopped. What the heck? Might as well write the whole thing down. Okay, another example. Ooh, there's one tiny little triangle on this picture. I need to find its area. For the similar figures at the right, find the area of the shaded figure. Well, all I've got is sides. 16. Sides ratio would be 16 to 3. Area ratio then would be 16 squared to 3 squared. If you would like to evaluate those, you may, which is 256 to 9. That is a 16. It kind of looks like my 6 smushed together here with a 1, which is 10. Let's see, 16 squared. There we go. All right, so this is your area ratio, 256 to 9. We want to find the missing area, so we say 256 is to 9 as 38 over A or A over 38. Big to little, should be 38 over A. Now calculate, this is going to come out small, 9 times 38 divided by 256 is what we can type. $1.33, that's enough, 1.3. Area of that little one, quite small, 1.3 square meters. Okay, we've got a couple more problems here, more practice. Find the missing area or missing side as requested. If you're given this picture, you're going to want to find A, the area. Sides are in a ratio of 8 to 5. We need to do 8 squared to 5 squared equals, I started with the first one, second one, every time 32 to A. You can just do this. You know, you got to find an area. You're going to have to square the ratio of the sides. So this is what it would look like if you wanted to write that as 64 over 25 equals 32 over A. And then cross multiply and divide. We're going to type 25 times 32 divided by 64. And I got 12.5. So the area of the second figure is 12.5 square centimeters. Okay, now what about this one? Well, they already gave us the areas. So we got to go backwards. Actually, why don't I go ahead and... Anybody want to divide those areas? I'm thinking, what is 4,590 divided by 510? It comes out nicely. Now, what happens if you just did that and you got the ratio of the areas is 9? How are you going to write it as a fraction? 9 over. How can you write anything as a fraction? Okay, 1. Thank you. I saw you. 9 to 1. All right, that's only the areas, though. So the sides would be in a ratio of, and you could have just taken the square root of those guys and then reduced it, I think. So sides are square root of 9 to the square root of 1, which is 3 to 1. All right, now you've got the side ratio. You take that, 3 over 1 equals, I want to find, I got to compare 21 to x, so I need 21 on top, x on the bottom, because it was large to small in the order I set up my proportion. Cross multiply and divide. 1 times 21 divided by 3. So x is going to be 7 meters. Did you get 7? Okay, you did something right then. Did you do the square root of this and the square root of that? All right, well, then I don't know what you did yet, but I'll be happy to look and see how it was. Now, the summary, real quick, and then we'll be done, and you guys can work on the problems. The ratio of the sides of the two similar figures is 2 to 9 or 2 over 9. The perimeters then are also 2 to 9, and the areas are 2 squared to 9 squared, which is 4 to 81. All right, you got your practice to work on, please.